Okay, so finally we're going to be talking about the interactions between all of the bonds, and then just a quick recap of everything that we talked about today. So we're going to start off with ionic bonds. So for ionic bonds, it's going to be between a metal and a nonmetal. So I'm just going to write M and then NM. Okay, so we have our metal and we have our nonmetals. And the reason that it's going to be forming between metals and nonmetals for ionic bonds is because of the want for the extra electron. So as we were talking about earlier when we were talking about sodium and then chlorine, is that the combination of those two, they're on different sides of the periodic table, so there's different electronegativity differences, and then also it's different between like the metals and the nonmetals. The sodium really wanted to get rid of that electron, and then the chlorine really wanted to take that electron. So that's the reason it's going to be forming between the metals and the nonmetals, is the want for the extra electron. So okay, so that's a want for the extra electron. So next we can talk about covalent bonds. So for covalent bonds, those are going to be formed between a non-metal and a nonmetal. And the reason that they're formed between those two is because unlike the ionic bonds, there's not a huge difference between like wanting to give up an electron and wanting to take an electron. So the valence shells are going to be closer to being full, and then also there's not going to be that like I really want one and I really don't want one, and the electronegativity is going to be a lot more streamlined and similar on that side. So you know that it's going to be between a non-metal and a non-metal. Okay, and then finally we will talk about metallic bonds, and we'll do that over here. Okay, so for metallic bonds, these are going to be between two metals. And these are going to be the most conductive ones because metals are more conductive than nonmetals. It's between a metal and a metal. And this happens for a lot of the same reasons between the other two, of just the want for the extra electron. So obviously for the ionic, there was a huge want. For the covalent, there wasn't much of one. And then same thing for the metallic bonds. There isn't that huge need for that extra electron, and they all want to share the electrons. So these are a lot more malleable, so meaning that they can move more, and this is why they're so much better at having the electricity flow through them, is because they're going to be moving more so that electricity can flow better through them. So the way that you would actually write these is if we had a bunch of iron atoms, so we'll just do 3 of these. So we have 3 iron atoms, then they're going to be sharing all of these electrons. So it's not really showing like, okay, this electron obviously goes with this one. It could be either one of those. They're going to be sharing it. They're going to be spaced equally apart because they're going to like repel each other. But with metallic bonds, there's going to be all of these sharing together for the common atoms, and then all of the electrons are going to be flowing around each other.